right hand, and I'm going to work from right to left. If you're left-handed, you would work from left to right. I want to position my torch tip within about 1/8 of an inch from the surface. Once I establish the arc, I'll tip the torch to about 15 to 20 degrees away from the direction of travel, which allows for better visibility of the weld puddle and accessibility of the filler material. I move the torch along the seam, making sure to keep it centered. If filler material is needed, I bring it in as low an angle as I can to help prevent hitting the tungsten and contaminating it. I progress the torch along the seam, adding filler material as necessary. Before preparing the tungsten, make sure to read the owner's manual for recommended safety precautions and additional information for proper grinding technique. I have my grinder set up with a diamond grinding wheel. Tungsten is a very hard metal, and although a typical grinding wheel can be used, you won't be able to achieve as good a finish on the sharpened tungsten, and you will wear out your wheel sooner than if it were diamond. You will want to hold the electrode parallel to the wheel as opposed to perpendicular. This ensures that the grind marks are running the length of the tungsten rather than across it, and aids the flow of current down the electrode. With a steady grip, I slowly rotate the electrode to form a point, much like you would sharpen a pencil. I want a point that is no more than 2.5 times the diameter of the electrode. This is how we would prepare the tungsten for welding mild steel, stainless, and chromoly. However, for aluminum, we would add one more step. We would take the sharpened tungsten and grind off the tip to create a flat spot or land. When that is complete, we would place the tungsten back into the torch with the ground end sticking out approximately 3/16 to 1/4 of an inch. When it comes to the weld appearance and warpage issues with stainless steel, it really boils down to one key problem. Too much heat is being applied. And a good indicator of this is the color change the weld area goes through. Typically we're shooting for a light straw to a nice salmon color. If you're getting those deep dark purples to a gray that looks dirty and heavily oxidized, that's too much heat. Not only does it not look good, but it also reduces the corrosion resistance of your stainless steel. Too much heat also has an effect on warpage. Stainless steel is unique in the sense that it doesn't transfer heat as quickly as other metals do. So again, too much heat in a localized area is going to make the material warp. How do we counteract that? It may sound simple, but just by simply reducing your amperage and increasing your travel speed will help decrease the amount of heat being applied to an area. Another little trick is if you reduce the diameter of your filler material because it takes less energy to melt a smaller filler rod. And because of this,